Hello everyone, hope you're doing well. Welcome back to my channel. Today we are at day 31st of the December daily LeetCode challenge. First of all, a big congratulations to all of you who have maintained their pace till now, who have maintained their consistency till now. And today we are at the last day of 2024. This is the first thing. And again, in this question, I will try my best because see, my aim is that after seeing this video, you should be able to be clear with all such questions at the same time. After solving this question, whenever such a question comes in review, you should be able to crack that interview. That is my aim. So I will be showing you total 5 variants of solutions for the same question. Remember, 5 variants, both Java and Python for the same question. That is this particular question. I will be showing you starting from the basic, like the kind of you can say brute force. We will go each optimization wise. We will go, and we will be reaching in a place where we are beating around 90% of the test cases in both Java and Python. Okay, I will show you both the solutions here. So please be with me, and at the same time, just remember, please be consistent. Today is the last day, and tomorrow we have another start, like when new year starting. Please be consistent. I'm definitely assuring you, you will get a lot to learn if you are maintaining this pace. Remember, it's not about how many questions you have done, it's all about how much consistent you were, because whatever learnings you had, you should be able to carry them forward to the next day. Okay, as simple as that. If you have not been consistent, you are solving once in a week and something like that, you will not be, that particular learning what you got from the last question, you will not be able to make use of it in your next time when such a question comes in the review. So that is something that I want to tell you. With this, I'm starting this question. Big congratulations once again. And this is not easy. Remember that this is not easy to maintain this consistency. So please try to be consistent. I am assuring that you will get some results in the coming years. So yeah, coming to this question, it is 783. I will be showing you 5 variants of solutions for this question. And by the end, the last solution that I will show you will be the most optimal solution possible. Okay. I will be showing you both Java and Python because many of you were asking me for Java solutions. So today I have included that as well. Okay, so let us go to this question. So yeah, it is question 783. Minimum cost of tickets is one of those first 1,000 questions called the golden questions of LeetCode. Okay, let us see that. You have planned some travel. Okay, let us see the inputs first, then we'll go to the question. So see here, some days are given to us. Okay, these days are going to be between 1 and 365. Okay, that one thing is clear. All the days are going to be in a strictly increasing order. That's what they mentioned here. The days are going to be between 1 and 365. The days are going to be strictly increasing. That is, there won't be any duplicates. Everything will be strictly increasing. That is, I will be smaller than I plus 1. Okay, ith element will be smaller than I plus 1 element. Okay, yeah, and the values will be one between 1 and 365, right? The length also, right? Now coming to this part, this is all about this, and then they were given cost. The cost will always be array of 3 elements, integer. All 3 elements are integers. Now let us see what we are given. You have planned some train traveling 1 year in advance. The days of the year in which you will be traveling are given as integer array days. Each day is an integer array 1 to 365. Okay, so these are the days on which you are going to travel. Okay, so these are the days. Now, so all the numbers in that are going to be between 1 to 365, and the length is also in the same range. Okay, length also can be up to 1 to 365. Train tickets are sold in 3 different ways. A 1 day pass is sold at cost, that is, yeah, this particular number is the cost for a 1 day pass. This particular number is the cost of a 7 day pass, and this particular number is the cost of a 30-day pass. Okay, that's what they're trying to tell you through this. Okay, now what is the meaning of these? So if you take this particular pass on any one particular day, only on that day you can travel. Okay, now if you take this pass, what will happen is you will be able to travel 6 more days, that is including today, 6 more days. So total 7 days you will be able to travel without any more ticket. Just this ticket is enough to travel on any of those 7 days. Okay, that's including today 6 days. Okay, sorry, including today 7 days. Yeah, that other than today there will be 6 days. Similarly for this, if you talk about this, the idea here is apart from today you will be able to travel for the next 29 days any number of times. Yeah, this is the price for that. Okay, now this is what they're trying to tell you. A pass allows you to, yeah, a pass allows that many days of consecutive travel. Okay, so you can travel, for example, let's say you take a pass here, so the day is 4. Okay, so you are taking 7 day pass here. So what will happen? So 4 plus 6, which is 10. Okay, so till day 10 you can travel without any pass. Okay, so if you see here, till 10, from here we are having these many days. Okay, so after, so the nearest to 10 is 8 here. Okay, so nearest number which is less than 10 is 8. So these 4 days you need not buy any other stuff, any other ticket, any other pass, if you have a 7 day pass on day 4. Okay, so I hope you understand this point now. Yeah, now for example, if you get a 7 day pass on day 2, then you can travel for these many days. Okay, so apart from 2, if you see you are getting on day 2, right? So just add 6 to day 2. So see, just add 6 to 2, you are getting 8. So eighth day will be the last day. Okay, so you are starting from 2 and just add 6, because see, 1 day will be in the day itself. Okay, that number 2 is 1 year. Okay, so if you add 6, that is, apart from this day you are having 6 more days to travel. Okay, that is how it is. Return the minimum number of dollars you need to travel every day in the given list of days. Okay, so the idea here is You are free to choose any of these tickets on any of the days, but you will have to travel on all these days, and you will have to predict what will be the minimum cost to travel on all these days. Okay, you are free to take on any of these kind of passes. Okay, 1 day pass, 7 day pass, or the 30-day pass, right? So if you come to example one, let me quickly explain what is happening here. See, there are multiple ways to do it, but let me tell you the one that I am thinking. See here, if you see on day 4, if I take a 7 day pass, what will happen? See, I am taking 7 day pass for these 4 days. Okay, the cost is 7. Now the remaining, that is the day 1 and the day 20. Okay, day 1 and day 20, I'm just taking 1 day pass, so it is going to be 7 plus 2 plus 2, which is 11. So that is what they have given here. Okay, so we'll come to see, they have explained some other way also. They are saying that if you take the 7 day pass from here, okay, you will be able to cover these many days, and yeah, something like that. You can try other ways also, like it's need not be fixed like only these 4 days I have to take 7 day pass. You can try it in the other way around. All right, you can do that as well. I think, yeah, this is the 7 day pass you can take in these two. The other 2 days you can take a 1 day pass, something like that. You can try that. Yeah, there are multiple ways to do it, but the idea is same. Okay, remember, the cost is important here. We have to return the minimum cost. It's not about the number of ways in which we can travel. It's not like that, right? Here, that's not the question. Here the question is the number of the final cost, right? Now you can go through example 2 as well, but what I want to highlight is that please go through the consideration once again. This is something that they have given you. Okay, so I am expecting you to use this in your solution if you are trying. Okay, so one, yeah, start, yeah, other than that, this cost, this is not important to us. Okay, because yeah, this is not playing any intro role. Even I tried in Java, like this is not affecting the data type. Okay, that's something that I want to tell you. This part is very clear. It is going to be till 365 days, so the length is also same, and the value is also going to be till 365. Fine, other than that, I don't see anything else which needs to be mentioned. Okay, now coming to the very basic solution that one can see when you see this question. First of all, if you are getting this kind of in a interview, the first thing that you have to do is you have to code a very basic minimal solution. I will show you the same. Okay, what you can come up, I will show you the same. This is the most basic solution that I can think. Okay, beyond this I cannot go. As simple as that, right? This is the most basic one. So what I'm doing here, I am first of all not making use of this fact. I am telling you this blindly. Okay, this fact I am not currently making use of this. Okay, this particular thing will come in my second solution. So the first solution that I'm showing you, I'm not making use of that fact. You see the first solution, what I'm doing, I am starting from day number 1. Okay, see, day number 1 I'm starting, and I will go till the last day. What is the last day? Last is the max day in the list. Okay, if you see here, the max day is going to be 20. So this particular loop, see, this particular function will be called every time between 1 to 20. Okay, so if you see here, I'm not going by the this array. Okay, I'm not going by this array. What I'm doing, I am calling this on every day. That is, I'm just doing a day plus 1. The idea here is I'm just checking whether on day 1 I am good or not, whether in day 2 I need a ticket or not, simply on day 3 if I need a ticket or not, in day 4 I need a ticket or not, like that. So I'm not considering like this. Okay, I'm only taking the max element out of this, which is 20, and then I'm starting from day 1 and going till day 20. Okay, I'll show you how it works. Just for basic information, just know that this could also be a possibility. So in case if you are interviewer is explaining you something different, you can think of this. Okay, just idea. Remember, this is the most basic solution that I can think of. Okay, so what we are doing, I'm first of all creating answer which is a float, that is infinite float. Okay, then I'm I'm creating set out of the days, which is called a planned day set. Okay, this is set now. This will help me of one time I can search the days, right? And the last day will be the max among the days. Okay, this is the the last day of which I need to travel in that particular year. Okay, and then I've created this particular function called, I'm just simply naming it as a function. You can give a meaningful name, that's up to you, right? Finally, I'm doing the function call and I'm returning the answer. So in this function, if you see what is there, first day is the day will tell me in which day I am currently at. Okay, I'm starting from day 1 and I'm going till the last day. Okay, in the example one, if you see, I'm going from day 1 and going till the last day 20. Okay, as simple as that. Now this will tell me the total cost involved for each day, like what is the cost involved, like till then. For example, I'm, let's say, day number 9. So till then, day number 9, how much cost I have spent, something like that. Okay, and this will tell me, like, if I have purchased a pass previously, so till when this pass is going to last, this will tell me that. Okay, for example, let us say in day 4 I have purchased a pass, so till which day this particular pass is going to last, this will tell me that. Okay, so let us see how it works. So in the function call, what I'm doing, I'm starting from day 1. The total cost is 0 currently. In the day 1 itself, I don't have any spending I'm not spending anything till now. And I'm the pass, that is the validity of the pass, that is, yeah, the passes till day, that is the validity of passes minus 1, that is the pass is not having any valid days. Okay, so I have to put, like, since I've not purchased any pass, so this particular number is minus 1 initially. Okay, this will tell me, like, till when I can tell without any pass. Okay, because the previous purchase pass is going to be valid till some day, right? So this will tell me that since I've not purchased anything till now, this will be minus 1. Okay, so what I'm doing, I'm just checking if This is the, remember, this is the terminating condition of the recursion. This is a recursive function. This is the terminating condition of that. So what I'm checking, if day is greater than last day. Okay, if I've traveled on 20th day also, and now I'm reaching the 21st day. Okay, this is for that. So once I reach the 21st day, that is, I'm reaching a day after the last day. In that case, what I have to do, I have to just capture the answer and then I have to return. Okay, as simple as that. So I'm capturing the answer. Answer is equal to any previous answer that I had. I come on the total cost as of now. Okay, the total cost, which is a parameter here. Okay, now then I have written. So this will stop the recursion from progressing further. Okay, this is one of the base condition which is stopping the recursion. Okay, it's a terminating condition. Other than that, see here, if let us say, for example, if you see here, I'm starting on day one, I'm not going to day two or three. That is day two and three, I'm not traveling. So for that reason, I've included this condition. So what is going to do? It is just checking if the day is not in the planned days. What is planned day? Planned day is set here. Okay, set of the days in which I'm going to travel. So if in a particular day I'm not traveling, what I have to do? Simply go to the next. That is just simply called day plus one. Okay, these two things remain the same. So whatever I'm getting here, simply same thing I'm passing it here. Okay, simply same thing I'm passing it here. I'm just incrementing the day and return. Okay, that's it. Now, if this condition is also not true, that means either there are two more possibilities. Now, what is that? So if this condition is not true, first thing is that, yeah, I am at a day in which I need to travel. Okay, this is the first thing. The other condition is that's here, whether I am having a valid password today or not. Okay, if I am having a valid password today, see, if the day is less than passes till day. Okay, the idea here is, if I am having a valid pass, that is, for today I did not purchase anything. Okay, I am having a valid pass from some previous days, so for that reason I did not purchase anything for today. So what I can do, I'm doing the same thing, or what I did here, right? I'm doing the same thing here. If you see, I'm simply creating day plus one. Okay, because I already have a pass. For that reason, I'm not going to buy anything more. Okay, so the total cost still remains the same, whatever was there previously, and I'm simply incrementing day plus one. Okay, I'm going to the next day. Now, if this condition is also not, that means today I have to travel, at the same time I don't have a valid pass. So what I need to do, I will have to purchase one. So what are the options for me to purchase? I have three options. Either I can go for the day one pass, or the 7-day pass, or the 30-day pass. So I'm going to try all of them now. Okay, I'm going to try all of them now. So what I'm going to do, see, this is the first case. Just I'm increment day plus one. Remember, in all three of them, day plus one will be there. Okay, now see here, in the first case, since it's a 1-day pass, so the pass will get over in this date, right? If I take a 7-day pass, so the pass will get over in next 6 days. Okay, similarly, if I take a 30-day pass, the pass will get over in next 29 days. Okay, similarly, if you see, I'm just including total cost plus costs of zero, that is the this particular zeroth index. Okay, this one I'm talking about. Similarly, here total cost plus cost of one, that is this particular 1th index. And similarly, next will be this second index. Okay, cost of two, cost of second index. Okay, that's what I'm doing. So I'm exploring all the three ways. Okay, so this is a recursion, right? So this will keep continuing. So if you see here, I'm this particular value will be different in each of the recursions. Okay, because this parameter is getting changed, so in every recursion this value will be different. At the same time, this will also be different. Okay, the idea here is, for the next 6 days I need not buy any more passes. Okay, so in the next of the 6 days, because of this particular condition, okay, I will not buy any more passes. This condition will help me to ignore those days that I am not going to spend any more fund on that particular days. Okay, because obviously here day plus 6 and day plus 29 I'm doing. So here the last parameter is this one, passes till date. So if the day is less than the passes till date, that means I will not buy any more passes on that day. Okay, as simple as that. That is, my current passes have valid even for that day, so I will not buy any more passes for that day. That's why I'm doing day plus 6 and day plus 29. So this particular thing will keep functioning. Okay, here I'm returning -1 initially, but this will keep functioning, and here I'm capturing the answer. Okay, and here I'm returning the answer. So let me quickly run this and show you how it works. This is the most basic solution, remember that. But yeah, from here we will be building the other solutions. Okay, don't worry, I will show you Java solution as well. Please don't worry. See, Python is very easy to read. That's why I'm showing you this solution. It's all about idea. Okay, once you get the idea, you can code in any language. I will show you the most optimized Java solution. So please be with me. I'm going to show you everything here. Okay, fine. So I've already shown you how it works. Now let us go to the other aspects of this question. Now we see here, since the days are in a strictly increasing order, that means we are wasting time here. Why? Simply I am doing day plus one. Okay, I'm going to to do the processing on each day, which is not needed. I should only do the processing on days for which we are going to travel. Okay, do you agree with me in that? So for that reason, this solution is not a good one. So the next solution, what we are going to do is, we are going to improve this part. Okay, here if you see, the only difference that I'm coming is, here instead of taking the day, I'm now going to take the index. Okay, what is this index about? Index will tell me on, and see, this index is about on which day. See, this index is for this array, right? The days array. It will tell me on which day I am currently. Okay, so for example, index 2 means I am on this particular day. Okay, so this is what index is all about. This is the index. So here I'm going to start with index 0. Okay, I'm going to start with index 0. The rest of the stuff remains the same. Total cost and passes, still this will remain the same. Some of the stuff will change. So here what I'm checking, if the index is greater than equal to n, that means we have reached the end. That is, we have traveled all the days. Okay, so for that reason we'll capture the answer in the similar way what we did previously. Other than that, this part will also change. If the days of index is less than the passes till date, simply do index plus 1 and rest of the parameters will remain the same. Other than that, we will be doing it. Okay, one if thing, if you see, the record reduces this part. This part is now totally removed. If you see, I remove this part completely because I will not be running this function on days for which we are not, traveling. So this part is totally removed in this particular case. If you see here, only there are one if condition and the other one is else condition. Okay, and this is the basic terminating condition for that part. Okay, so if you see, it's totally removed now. So this part is exactly same. Okay, these two parts are exactly same now. Okay, what we said previously, only this particular part is removed now. Okay, now, so this is the second solution. Again, this is not optimal solution. I will tell you why, but let me run this first. As you can see, this is clearing the test cases. Okay, now, first thing why it is not optimal is, see here, try to understand the case here. Okay, yeah, let us say this way. Okay, for example, okay, let us say I took if 7 day pass here. Okay, so yeah, so till day 7, okay, I am good. Till day 7 I am good. Again I'm going to start on day 8. Okay, see, remember one thing, this is a small example. Okay, but try to understand it how it will happen when the input is bigger. Okay, so see this part. See, idea here is, if I have already done a calculation, that is, if I know, like, if I start on day 8, okay, if I have to again buy a ticket on day 8, so which ticket will be most optimal to buy on day 8? Okay, let us see this calculation first. So if I have that calculation, I should not do that calculation again. That is the basic idea. The idea here is, we should not solve some problems again and again. If we have a common sum problem, it should be solved only once. Okay, that is the basic idea. So I'm, trying to teach you how the recursion idea is coming here. Okay. So how, let us see here. Let us say I have purchased this 7 day ticket on day 1. Okay. So for these 4 days I am good. I don't have to worry about any ticket. But on day 8 again I will have to worry. I will have to decide among the three options which ticket should I buy on day 8. Okay. So whatever is optimal, let us say we have purchased it. But the idea here is, once we decide whichever is optimal, that particular memory should be maintained. Okay, because here, by instead of buying the 7 day ticket on day 1, let us say I purchased one day ticket on each of the days. Okay, 1 day ticket here, 1 day ticket on day 4, 1 day ticket on day 6, and 1 day ticket on day 7 again. Still I will come to day 8 again. So day 8 again I will have to process. So I'm just trying to tell you how the day 8 sub problem is common in some other problems as well. Okay, so if you see, day 8 can come where, if I purchase a 7 day ticket here, then day 8 problem will come. Okay, day 8 again I have to purchase something. Similarly, if I purchase 1 day tickets for each of these 4 days, again on day 8 I will have to purchase something. So the idea is, if I already calculate which is the best way for date, that is from date, if I start and go till the last, then which ticket will be most optimal to buy on date? If I have that calculation already done, I should save it somewhere. For that reason, now we are going to think about the cache. Okay, so here comes the cache. So idea of cache came because we see that there are some problems which are repeating. To avoid them, now we are thinking about cache. So the solution that I'm going to show you currently is one of the most optimal solutions. But yeah, after that again I will show you one more solution. Like, we'll just add one more optimal case here, that will become the most possible optimal solution. Okay, first pay attention here. See, here we have introduced the cache. Okay, we have introduced the concept of the cache here, which is simply a dictionary in Python, right? So this condition will remain the same. Okay, what we are checking, if the index is greater than n, then we are simply returning the total cost, right? This will remain the same. Okay, if you see the difference on the part is, see here what we are doing is, we are just calculating the answer in the base condition, that is in the terminating condition. Okay, this is the terminating condition, right? So in this condition, we are just, like, before terminating it, we are just capturing the answer, but we'll have to change the whole structure now. So what we are doing now, see, now I am going to introduce the return statements. Okay, till now if you see, we are not returning anything. We are simply, returning from the function, but we are not returning any value. But here we'll have to change the structure in order to cache the things. Okay, so if you see here, what I'm going to do now, okay, let me first show you how the caching is working. If you see here, basically, see, the cache will tell me on a particular day. Okay, on a particular day, if I start, okay, for example, let us say I'm going to start on day 20, so which is going to be the most optimal ticket for me to buy. Okay, so it will tell me, for example, on day 20 the cost 2 is most optimal. Okay, because if you see, if I start on day 20, I only have to travel on one day, so cost 2 is optimal. Now if I travel on these 6 days, okay, 6, 7, and 8, if you see the values, let us see the value for date. Okay, if you see the date value, it is saying 4. What is the meaning of 4? That means if I start on day 8, I will have to spend $4. Okay, why 4? Because that is 1 day pass for each of these 2 days. Okay, that's why day 8 it's showing 4. Okay, now if you talk about day 7, so what is the value for day 7? It's showing 6. Why? So that is 1 day pass for each of these 3 days. Okay, each pass costs $2, so 3 to $6. Now, if you talk about day 6, again same thing here. The same thing. If you see, there are 4 days here. In each of the 4 days, I'm going to buy a 1 day pass which costs $2. So 4 into 2, 8. So if you see the value for 6, it is 8. Now comes the difference. Now see the difference here. Now day 4, now it is showing 9. How it is coming? See, if I buy a 1 day pass for each of these 5 days, so what should the cost? The cost should be 10, but this shows me 9. How I'm getting this 9? The idea here is, if I buy a 7 day pass here, which is going to cost me only $7. Okay, so these 4 days I'm going to cover in $7. For the last one day, I'm going to take a $2 ticket. So 7 plus 9, sorry, yes, 7 plus 2 is 9. So that's why for 4 it is showing $9. Here the difference is coming. Okay, now see here, that this is going to tell me, if I start on day 4, okay, then if I have to cover till the last day, a $9 will be a enough amount for me. Okay, this particular thing we will be using for day 1. Now if I start from day 1, and now I already have the calculation for day 4. Okay, so in order to reach from day 1 to day 4, I just need a $1 ticket. Okay, so that is the basic idea. So that's why, if you see in the calculation for day 1, we are just adding a 1 day pass cost to the day 1. Okay, here it is 9, just add 9 plus 2, which I'm getting 11. So the idea here is, for each of the sub problems, I'm breaking the solution, I'm saving it. Okay, I'm caching the values basically. Okay, so that is, if I start on this particular day, what amount should I have, okay, to complete till the last of the days from here. Okay, so that is what I'm trying to cache. Okay, this will be the cache. So if you see here what we are doing, if the index is greater than, then simply return the total cost. This is one of the terminating conditions. Okay, instead of if you see in the previous solution what we did, here we are just capturing the answer and we are not returning anything, but here we are starting returning the total cost. Okay, now see here. Yep. Yeah, this part will remain the same. Okay, this part will remain the same. If you see here what we are doing, if the days of index is less than the past detail, that is, we are having a pass on a particular day, we did not spend anything on that day. Okay, so what we are doing in that case, I am simply returning whatever the function is returning. Okay, because on this particular day, I don't have to spend anything additionally. That's why I'm just returning whatever the function is returning to me. Okay, if you see the return, the same thing whatever the function is returning. Now, here comes the most important part. If this condition is also not true, that means I am forced to buy a ticket. Okay, see, if this condition is true, that means I need not buy it something here. Okay, whenever I need to buy something, only then I need to see the cash. Okay, so this is the part here. If I'm just checking, see, if this condition is not true, that means I have to buy something. Okay, so I'm just checking whether this particular day, okay, days in, that is the index. Okay, this index, what is the value in days, if this particular value is there in my cache. Okay, if this value is there in my cache, simply take this value out and just add it with the total cost that we have seen till now. Remember, total cost is coming from the past. Okay, for example, see here, if I talk about day 7, okay, this, well, that the cache will tell me, if I start in day 7, how much money I need to optimally pass all the remaining days, okay, forward. But if you talk about the previous 1 or 2 3 days, for that the cost is coming in the total cost. For the forward 3 days, I have to get the cost from the cash. Okay, so this is how it will work. So what you have to return the cost for the next 3 days, comma, that is plus the cost for the previous days that I've spent already. Remember, this cost depends on what you have done previously. Okay, what is you have done in the past. So this cost you have to add to this cost, which will tell you, see, this particular stuff is the most optimal cost for the future, but this cost will tell you what is the most that the cost that you have chosen for the past few days. Okay, that's why you have to add these two and we have to return. Okay, this is where the index is coming in, playing a role. Okay, fine. If the cache is not there, let us say if the cache is not there for this day, so this condition itself will not be true. Okay, so in that case we'll have to do the calculation. So what I'm doing, first of all, I am calculating for a 1 day pass. Let us say this function return some cost, I am calling it as a k. Now I will again run the same function for a 7 day pass. Okay, whatever is the value coming, I am comparing it with the k, and whichever is the minimum, I'm showing it in k. Okay, similarly, I'm again calling the function for a 30 day pass. Whatever is the value coming, I'm showing it in k. Sorry, the minimum value, I'm showing it in k. Okay, if you see here, k first I got from here, then I'm comparing the value written by this function and the already value there in k, I'm showing it here. Same thing I'm doing again, I'm calling this function and I'm comparing the already existing value in k, and which is the value, I'm showing it in k. So at last k will have the most smallest value. So this value I'm going to cache now. See, this is where I'm doing the caching part. Okay, if you see what I'm doing, I'm just doing in this particular key, add, that is cache this particular value. Okay, this, remember, caching is a k. See, this particular stuff is called a mapping in Python, right? It will store key value pairs. Okay, this is going to be the key and this is going to be the value. Okay, this value is cache now. Okay, so what you have to return at the end, we have to return k plus the total cost. Okay, So this value is k plus the total cost. Okay, this will tell me how much cost we have spent previously, and this will tell me how much cost we are going to spend, that is most optimal cost to be spent in future. Okay, that is from current day onwards. If I have to go till the last day, how much dollars I will have to spend most optimal way, right? This will tell me that. This function I'm calling, okay, I'm passing 0 0 minus 1. Why like that, I will show you. Index is 0, I'm starting from index 0. Fine. Total cost on day 0 is that is, see, when we are in day 0, right? Remember, index 0 is because we are following 0 index. Okay, this total cost will tell me that on the first day, that is on the 0th index, the day. Okay, so we did not spend anything. Okay, when we started, we spent 0. That's what it's trying to tell you. This will tell you that since on we have not purchased anything before starting this function, that's why passes till day will be -1. Okay, as simple as that. Finally, I'm printing the cache and I'm writing the answer. Let me quickly run this solution and show it to you. Remember, this is one of the optimal solutions. You can segment this as well and it will get accepted. Okay, this will solve all the test cases and will be accepted. So yeah, you can just go through this output, how it works. Even for example 2, you can go through the output. Okay, this will tell you some of the very good stuff. Like, the idea is very simple. You will start on a particular day. Okay, for example, yeah, let us say you start on day 6. So for day 6, how much money you have to spend for covering the remaining days, okay, till day 31. It will tell you the cost for that, most optimal cost for that. Okay, remember that part. And we, since there will be some problem in other problems also, so this will be cached. Okay, as simple as that. Now, this is one of the most optimal solutions. Okay, just comment the print statement and yeah, segment the solution and this will get accepted. Fine. Just one more automation that we are going to add is, just pay attention whatever we are having here. Just take a look here. Now I will show the next solution in which another automation is being added. Okay, so yeah, this is the next solution. The only automation that we are adding is this part. Okay, this is the only addition part that we are doing. Yeah, this particular part. If you see here, these three calls we are already doing fine, but we are adding another if condition here. Okay, in this if condition, the else condition will have these three function calls. So what we are doing, see here, the idea is going to be very very simple. I will show you one test case also where this will be relevant. See here what is happening. I am just checking whether the index plus 1 is existing, that is index plus 1 is less than n. Okay, that is, it is existing. We are not in the last index. Okay, remember that part. Just only for that I am checking. And if this exists, that is if index plus 1 exists, then what I am going to check, I am just checking whether the days, that is the next day in which I will be traveling minus the current day. Okay, I'm just seeing the next day in which I will be traveling minus the current day. If it is greater than 29, that means idea here is, for example, okay, let me show that one of the test cases here. Yeah, see this part. Okay, I guess, yeah, I am not having that. Okay, let me show you here. For example, something like that. Let us say you travel on day 2. The next day will be, you are going to travel on day 65. The idea here is, even if you take a 1 day pass or a 7 day pass or a 30-day pass on day 2, it is not going to have any use to you in the next day. Okay, the idea here is, when you come to day 65, you will again have to take some pass. So that is the reason I am trying to check. Okay, so if you see here, the idea of calling all these three functions is that maybe if I take a 7 day pass or a 30-day pass, in the next day it will be useful to me. Okay, but if I am sure that, see here, the day 2 and day 65, obviously if I take any pass on day 2, it will not be useful on day 65. Okay, so that reason I'm going to check this. Okay, if days of index plus 1 minus days of index, that is if 65 minus 2, okay, if it is greater than 29, that means if I take any pass, it will not be helpful on the next day. Okay, for that reason what I'm going to do is, I am going to take the min cost pass, that is whichever pass has the minimum cost, I'm going to take that. Okay, if you see here, I'm calculating this min cost pass. It tells me which pass is the minimum cost. Okay, in this case, if you see, the day 1 pass is the minimum cost. Similarly, in some other cases, some of the, for example, sometimes the day 7 pass is the minimum cost. Remember that this can happen. In the question, they have not mentioned that always the day 7 pass will be higher cost than the day 1 pass. It's not like that. Okay, it can happen that day 7 cost is small, that's having less cost than the day 1 pass. Okay, for that reason, whichever yeah, pass at the minimum cost, I will take that on that day. Okay, min cost pass I will take, and I'm simply marking as -1 because anyway I know that in the next day I will have to take a pass. Okay, so this doesn't make any sense to allot any value here. Okay, so I'm simply giving it as a -1. Okay, so this is the only addition that I'm making it here. And yeah, remember, this is one of the edge cases to handle the outliers. Okay, as simple as that. As I mentioned, something like this. Okay, let us say you're having 365 here. Okay, yeah, you're having 365 or 364 here, or 363. So in that case, this will be really useful. Okay, you know that anything that I take here will not be useful on the next day. For that reason, I will take only the pass which has the smallest cost on day 2. Okay, something like that. So this is one such outlier. Okay, these are some of the edge cases where, instead of doing the recursion, and that is instead of taking all the things and calculate again and again, what we can do is, whichever has the minimum cost, you are just taking that. Okay, and you're not bothering about the next day. Okay, and the next day we will recalculate, right? That's what we are doing. Okay? If this is not the case, only then we will be calculating all the three. That is, if I take a 1 day pass, a 7 day pass, or a 30 day pass, which way will it will be best, like that I will be calculating. Okay, that is something that I want to tell you. At last we'll be saving the value, that we are caching the value, and we are returning this. Okay, as simple as that. Yep. So this was the final solution that I have. I can give you the solution in the comment section. Go through it. Okay. It is around running around, I guess, 7 to 9 milliseconds. It is taking in Python. And I'm talking about the final segment. Okay. When into the final segment, it will take around 7 to 9 milliseconds. It is really waiting most of the cases. Okay. In terms of space complexity, this is really optimal. Now the same thing if I have to show you in Java. Okay. This is the Java solution for that. It is taking, I guess, around 3 milliseconds for all the final test cases. I guess there are 70 test cases. For all of them, this is taking 3 milliseconds. So the exact same thing. Okay, let me go through some of the important ones here. So see, since in Python we cannot have a function inside, sorry, in Java we cannot have one function inside another function. For that reason, I am creating this function. Okay, let me zoom out first. Yeah, if you see, I'm creating this function separately. I've kept it as a private function. Okay, because this will be called from inside the class only. Okay, and this is the original function. If you see inside the class, I've created some of the variables, whichever variable I need in the both are functions. I'm creating them here. For example, n, then the min cost passes, then cost days, everything I'm declaring here. Okay, and then I will be just referencing them here. If you see, I'm doing this. This dot cost equal to cost. This dot days equal to days, this dot n equal to days dot length, and here I'm initializing the cache. Okay, it's a hash map. I've already passed n because there will be at most n keys. So for that reason, I'm just passing n so that it doesn't have to re-add some memory into it when it exceeds the given memory. For that reason, I'm passing n also. Okay, then yeah, this is something important that according to me you will not be knowing is this part. See, now to get the minimum value, okay, for array, integer array, what you have to do, you have to use the stream function. I'm calculating arrays dot stream, pass the array here, the cost array is, I'm passing it here, then I'm doing a dot min, and then I'm calling the dot get as int. Okay, this will tell me the minimum value in the array cost. Okay, so that I'm calling it as a min cost pass. Okay, so this I will using when, as I mentioned in the last case, this I will be using it here. Okay, when the current day and the next day there is a difference of more than 29 days, in that case I will be using the min cost pass. Okay, as simple as that. And yeah, rest of the things are remaining the same. Here I'm calling the function, and whatever is the return value from this function will be my answer. Okay, so let's see what we are doing it here. So these things I've already mentioned, I've declared it here. I'm initializing the bit here. Okay, I'm initializing all of them here, right? So inside this function, if you see, it's exactly the same what I showed in Python. That's why I always show the Python first, because it's very easy to understand that. Okay, here the number of words let's the typing you have to do is more in Java. Okay, so the same thing. This is the terminating condition. Okay, yeah, as simple as that. Then if the days of index less than the past till days, okay, that is, you don't have to buy any pass for this condition. Okay, so we are just doing index plus one and then moving forward. Okay, as simple as that. Next, if my cache contains the value here, okay, if the cache contains this particular value, simply return the value that we have after adding it with total cost. Okay, as simple as that. Fine. Then if this condition also not true, that means we'll have to recalculate the stuff. Okay, for that is I'm declaring k. Now I'm just checking whether index plus one exists, and days of index plus one minus days of index is greater than 29. That means if I buy a current ticket today, any ticket type today, it will not be useful for the next day. Okay, next day in which I have to travel. For that reason, I will choose the pass which has the minimum cost for that reason. Okay, as similar that this for that. Other than that, yeah, we are exploring all the three cases. If this condition not true, if this condition not true, we'll have to explore all the three cases to understand which is going to be the best. Okay, that is the pass for the day one, pass for 7 days, pass for 30 days. We have to explore everything. We are storing everything in k, whichever is the minimum. We are going to store it in k. Okay, I'm calculating all of them. I'm comparing with them with k, and we're storing it. And ultimately, we are caching the value. This is how we do it in Java. And finally, we return k plus total cost. Okay, fine. One thing that I want again repeat here is, see, why you, when you import math library, remember one thing, this min function, right? Remember this part. I have seen this in an interview. Also, they ask this question. See here, the min actually, if you remember, no, it's a, yeah, you will have to always call it with math.min. Okay, because the way it is defined, okay, it's a static function. So static function will always have to call it using the class name. You simply cannot write min. Okay, you cannot simply import some people write java.math.min, they will write, and then they will simply call the min function here. They will not write math dot. Okay, that is not allowed. That will not work because min is a static function. For that reason, min and max both. So we'll always have to do math.min only, or math.max only. Okay, so just remember that part. Fine. Simply we are caching it and we're returning this particular part. The rest of the stuff I've already explained in Python solution, so I'm not going to them in detail. But yeah, this solution is slightly faster compared to Python in terms of time. But again, remember this part, in terms of space, Java will take more space compared to Python. So it's always both sides will have to compromise in somewhere. If you want a very fast solution in terms of runtime, Java is good. But sometimes what will happen on the JVM part, it will consume some more space. Okay, so for that reason, if you go for the Python solution, it will not be that much fast in runtime, but the space that will consume is very, very less. Okay, so anyway, this is the most optimal solution that I'm giving you. Yeah, that was all. So yeah, friend, that was all for this question. I hope you now got a very good understanding of what it is this was the last day of 2024. So I thought of giving my best to you on this last day so that you get a lot of confidence in solving this kind of questions. So whenever this kind of question comes the next time in your interview, please be mindful to start with the most basic approach, go till the very last approach, and never say never. The idea here is never say that no sir, I have reached the most optimal solution. You cannot ask that, you cannot say that there is more optimization possible. So you cannot say like that. Okay, you'll have to go through every aspect of it. Okay, for example, this particular aspect what I've explained here. Okay, if the next day is more than 29, okay, the difference between them is more than 29 between current day and the next day. So you see there are always optimizations like this possible. Okay, so you can always think of them. Okay, so never say like no, I've reached the most optimal solution, still I did not get selected in that. It's not like that. Okay, you have to start with most basic thing, then slowly by slowly everything that you might see here, you have to tell them that okay, this is the fact now, I'm going to consider this fact now, and then this is how the solution will look like. And yeah, then keep optimizing thing, then keep introducing the cache. See, you have whenever you introduce the cache, that should be a reason, right? You simply cannot say no, I learned like this, that's why I'm using. Not like that. As I mentioned, there are cases that I showed right in the example, right? For example, in the day 8. So at this day it will come multiple times. Okay, this problem will come multiple times. In order to save the calculation on that, we are using cache. Okay, so this example I showed you, and then we come for the most optimal solution. We added most of the conditions here. Okay, we added some of the conditions to optimize the stuff. Okay, and finally I showed you the Java equivalent for the same. So you have to come to solutions like this. You have to do multiple things like that. Keep moving, keep moving. Remember, if you get this kind of questions in an interview, they expect you to at least 2 to 3 solutions they expect from you. Okay, that's why I always start with the most basic one, then go through each of the constraints, each of the words given in the question, then show them okay, because of this reason I'm optimizing this, and finally I'm reaching it here. Only then they will select you if you're able to explain everything, if you're giving every reasoning for choosing something that you're doing. Okay, remember this part is most important. You can solve the questions, but still you will not be selected for the interview. This is the reason for that. Okay, you're not explaining properly, you're not going by the step by step approach. That is, you are simply coming to the optimal solution. That will give you an impression that you have remembered the solution. That is, you saw the solution somewhere else, so you're simply recalling and writing it here. This is not the right way to solve an interview. Okay, yeah, and that was all for this video. I hope you learned something. I can give the solution in the comment section. Go through them, simply add some print statements and go through them, understand why it is functioning, and come with me with your doubts. I will definitely clarify your doubts. Okay, yeah, and that was all for this video. Please subscribe to the channel. Yeah, see you tomorrow in 2025. Till then, happy new year to all of you. See you tomorrow.